Hi, my name is Aisyatu Khadijah binti Muhammad Sharif Kamal Baluramo. My number metric is 33DPE19F1012. Dr. Dolina binti Tolibun is my lecturer for this heat transfer subject. In the first place, now I'm going to explain about basic concept of heat exchanger with the working principle of heat exchanger and the log mean temperature difference method, or it is well known as LMTD. So, heat exchanger is an apparatus that has two streams of fluid that exchange temperature to heat or cool the system. And the working principle of this heat exchanger is normally in all kind of heat exchanger, it normally heat flows from higher temperature to lower temperature. So therefore, the hot fluid and cool fluid are separated by a heat conducting surface such as metal, but it still can transfer the heat from the hot fluid either from the cold fluid. Okay, so the essential principle is that heat transfer transfers heat without transferring the fluid that it carries in the heat exchanger itself. So in this animation shown in my slide, we can see there is two types of flow in a heat exchanger normally, which is countercurrent flow, and another one is parallel flow, which means the countercurrent flow has the different direction of two streams of fluid, which is they move vice versa. Okay, while the parallel flow shows that the two streams of fluid flow in the same direction. So now I'm going to explain about the log mean temperature difference, or it is called as LMTD. So LMTD is a logarithmic average of the temperature difference between hot and cold stream at each end of the heat exchanger. Generally, in heat exchanger has two ends. We can call it as A and B, at which hot and cold streams enter or exit on either side. So LMTD is defined by the logarithmic mean as follows, which is LMTD equals to delta T1 minus delta T2 divided by ln times in bracket delta T1 divided with delta T2. Delta T1 is the temperature difference between hot and cold fluid at one end of the heat exchanger, while the delta T2 is the temperature difference between hot and cold fluid at the other end of the heat exchanger. So there is following equation is used to calculate overall heat transfer across a heat exchanger using LMTD, which is Q equals to U times A times LMTD. So here we can see that Q stands for overall heat transfer across our heat exchanger in watt, while A is the heat exchange area, while U is overall heat transfer coefficient in watt per Kelvin meter squared. So now I'm going to explain about plate and frame heat exchanger. So as everyone knows, or they don't know, or now they might know, that plate and frame heat exchanger, also known as PHE, the short forms for the plate and frame heat exchanger. So I can simply call it as PHE then. So at this one, I will present about the working principle, the construction of PHE, the component used to construct the PHE, and the advantages and disadvantages of the plate and frame heat exchanger as well. So first we see the working principle of this plate and frame heat exchanger, which consists a series of parallel plates that are placed one above the other, so as to allow the formation of a series of channels for fluid to flow between them. And then there is a space between two adjacent plates forms the channel in which the fluid flows, and then the inlet and outlet at the holes at the corners of the plates allow hot and cold fluid through alternating channels in the exchanger, so that a plate is always in contact on one side with the hot fluid and the other with the cold fluid, so they won't mix together. And then the figure shows at the right side of my slide, the figure shows that the the flow of fluids inside the exchanger, which is the fluid are divided into several parallel streams and can produce a perfect countercurrent. This is because of the gasket, okay? So, and the channels. Okay, so the water or those streams, the cold water and the hot water won't mix together. So let me explain the construction of PHE. This is the construction of PHE. In this construction, the main elements are fixed, which is frame, gasket, connecting part, and plates, and it is composed in series of plates with parts for fluid entry and exit in four corners. And the plate pack is tightened by the tie bars, and the leakage is prevented by using gaskets. The component used in this construction is plate, of course, to perform as the heat transfer surface, the gasket to seal and channel the flow between the plates, the frame head to perform as pressure retaining structure for plates, and the carrying bar at the top of it, it carries the channel plates and the pressure plates, and the follower is a removable seal plate which helps to assemble and disassemble when there is necessary stuff to do, like service of cleaning. Okay, and the tie bar is the second important thing because it will help to press the channel plates together. So now we can see the advantages and the disadvantages here. Okay, so first of all, advantages is to minimize risk of internal leakage, and it is easily detectable when there is any leakage in the construction. And in this PHE, it has the high heat transfer coefficient, and it is very compactable, and there is no insulation needed in this construction or in this heat exchanger, and there is low fouling characteristic. While there is the disadvantages, also there is disadvantages, which is there is limited pressure use. Okay, generally not more than 1.5 megapascal. Okay, and then the second one is limited operating temperature due to the temperature resistance of the gasket material. Okay, so that is the reason why the gasket must be high in quality. Okay, it must be good in the qualities. Okay, and then it has the small flow path and not suitable for gas to gas heat exchange or steam condensation, and there is high possibility to have some blockage in the plates, between the plates, if there is any suspended solids in this fluid, and the flow resistance is smaller than the shell and tube heat exchanger. So that's it from me, and these are the reference that helps me to complete my presentation. So thank you. Assalamualaikum and goodbye.